see how a botanical air filter could perform in an energy efficient residence. So with this, I'm going to talk about my experiment and specifically what I've been working on. So what I wanted to do is, previously with the biowall, they had a proof of concept and they could kind of generally show that it was improving indoor air quality. But what I wanted to do was specifically target different parts of indoor air quality and show with scientific credibility that we could improve indoor air quality, and then run that through an energy model to see what the impacts on energy efficiency could be. So that's kind of, for the people who study statistics in here, I've got my null hypothesis and my alternative hypothesis for, conducting testing there. And then the table at the bottom just shows some of the basic criteria that we wanted to meet for the project, as far as improving indoor air quality concerns, reducing energy consumption, and then looking at some of the more qualitative aspects of the biowall. How much maintenance is required for it, or what's the visual appeal, and how healthy are the plants. So how is it designed? So the biowall is basically a stainless steel plenum that has a vertically standing growth medium in it that's got the plants growing in it. We made the growth medium and the trellis that's holding the growth mediums out of different materials, and it's what we call modularized trellis. And the reason for this is if one section of plants isn't doing well, or if we want to experiment with different kinds of plants, we can actually just swap those out using different modules within the trellis. The plants are provided everything they need. It's a completely automated system. Well, not everything, but we tried to make it as low maintenance as possible. So they've got artificial lighting that provides as much light as they need. We've got an automated watering system, which includes nutrients that are siphoned into the water stream, and then the drainage system is also automated. So we tried to design it as low maintenance as possible. I think that hits most of the points there. The other thing that I wanted to mention is that since we're studying energy efficient residences, we wanted to take our biowall and kind of simulate an energy efficient residence through this experiment. So that kind of brings me to the next point. Where did we put this device? We put it in an environmental chamber in the Applied Energy Lab at Purdue. And what we tried to do is we sealed up that environmental chamber just like you can imagine a sealed building. And inside it we had the biowall with this recirculation system. You can see the blower on top of it. And it's just recirculating air within this sealed chamber, similar to how a return air system might work in a house. Inside the test chamber, we had the biowall, we had all the automation, we also had sensors and other things of the sort to measure, the amount of indoor air toxins, carbon dioxide, temperature in the chamber, relative humidity. And we actually had a number of different systems all monitoring similar variables so we could be more confident about what we were monitoring and what was happening. And then outside the test chamber was kind of the basis of a lot of these, it was kind of where a lot of the sensors were controlled through a LabVIEW program, for those of you who've used that before. So what is the experiment itself? So the idea is, and this is based off of previous research, it's what's called a pull-down method, which is basically we take the chamber, we introduce some sort of contaminant. In this case, we took a small amount of toluene, which is just a VOC, and introduced that into the chamber by evaporating it quickly, close the door, have it kind of generate this VOC in the chamber, and then slowly watch the decay of toluene over time. We can then look at this under a number of different scenarios and compare those decay rates. So we did once with the biowall and once without the biowall, and then compared those two decay rates to see how the presence of the biowall affected those decay rates. And so there were kind of 5 things we were really looking at. So when we did the test without the biowall in the chamber, the 2 main variables that we were kind of studying there were how quickly do the VOCs adhere to the surface of the chamber or deposit on the sides of the chamber, just because that naturally occurs as air gets recirculated in there, and also how quickly is air leaking out of the chamber. tried to seal it as best we could, but it's still, we had maybe about 1 CFM of air leaking out of there most of the time. And then with the biowall, that included both of those variables I just talked about, and also the effects of the plant microbes, which it goes back to what I was saying before, where the microorganisms in the plant's roots are what's breaking down these volatile organic compounds in the air. You'll also see two other categories, adsorption and absorption. Both of those we consider to be negligible, and that gets a little bit more technical, so I'm going to stay out of that. But if you have questions about that afterwards, I can talk about it more. So what are the results? So the first thing we did is, and you actually can see the beginning of that test in this image over here, we took a 24-hour average sample of the biowall in the chamber just to see if it had any effects on the indoor air environment, whether, maybe the plants are introducing VOCs, maybe there's already VOCs present in our chamber. And so we took a 24-hour average sample of that, sent it off to a lab for a more sophisticated form of analysis, and got the results back from that. So basically what we found is that our environmental chamber doesn't really have VOCs in it. You see two lines on there, but the point I'd like to make is that the concentration levels you see are in parts per billion. A lot of the work we actually did in the other testing was in parts per million. So you can see that there's an order of magnitude difference in just what was ambient, in the ambient levels versus what we were actually working with. The two substances we found, Freon 11 and methylene chloride. Freon 11 is present in a lot of insulation, so we thought that was part of the environmental chamber itself. And then methylene chloride, we're speculating that came from the manufacturing of the motors. So this is kind of the big graph of the experiment, and this is kind of, one of the things we've been targeting since the beginning is how does it improve indoor air quality. So on the y-axis you see the normalized toluene concentration, and that's just, looking at how much toluene we have in the chamber at a given time. And then on the x-axis you have how long into the experiment are we. And just as I was saying, we have a generation time, which is kind of the curve up, and then kind of a static period where it's peaking, and then it starts to decay. The red line is without the biowall, and blue line is with the biowall. So you can see that without the biowall, it took much longer for it to decay than with the biowall. And the difference between those two is really about how much filtration we were doing using those plant microbes. Another thing we looked at is particulates. So a lot of times when you talk about this project, people are interested, if we bring in a bunch of plants into our house, is that going to affect my allergies? Well, we decided we needed to look at particulates to see, is the biowall going to create a lot of particulates? At first glance, this graph might seem like it is introducing a lot of particulates, but what we found is that it's in 2-hour intervals that this spiking with the blue line that you see occurs. And what's really happening there is that our spray irrigation system is turning on, and it's those mist droplets that are spiking the particulate levels. So the take-home message from this graph is that no, it doesn't look like there's any increase in particulates as a result of introducing the biowall. And then something that was a little bit more intuitive for this and kind of more expected was looking at the relative humidity gain. So if you take a bunch of air and you pass it over something that's really wet, you would imagine that that air would pick up some moisture while you do it. Well, that's basically what we found, is that we pass air over it, it picks up some relative humidity, and as a result of picking up relative humidity, it decreases the temperature. It's kind of like when you're at amusement parks and they've got those spray systems. It's a really hot day and we'll turn on the spray system and it cools you down. It's the exact same concept where it sprays humidity out and that kind of decreases the temperature. So how did the plants do? We tried a number of different plants. We had 8 different species and 2 different growing mediums. And you can see that over time the plants became more healthy. We tried a couple different configurations of how we set up the irrigation system. We started out with it behind and eventually moved it to the front. But basically you can see a progression there over a couple months before the test where the plants are getting more and more lush and improving their health. So we've talked about indoor air quality, and we've shown that there's an improvement of indoor air quality, and also that there isn't any sort of degradation as a result of particles. There aren't that many VOCs present, and things along that line. So the next step is looking at energy efficiency. So how does this improvement in indoor air quality relate to energy efficiency, and how can that be incorporated into the built environment to help reduce natural resource consumption? So to begin, we started building an energy model, and what we did is, since the biowall has its roots in the solar decathlon house, we figured we'd base our energy model around that house. So it's a one-story house, it's 1,000 square feet, and it was a lot of the same assumptions. So just a similar HVAC system and things along those lines is what was the basis of that energy model. And I'm not going to dwell on this. Basically, this is just to give you an idea of some of the equations. And for those of you who have taken a thermodynamics class or anything like that, it's just a lot of conservation of mass and conservation of energy stuff that allowed us to do these calculations. And so the primary components were the biowall, a air handling unit, the zone conditions,